How are we doing here? This is Mike, and in this video we're going to discuss the relationship of even and odd trig functions, and then also discuss what happens when we invert the ratio of trig functions. And this is distinguishably different than inverse trig functions. When we have an inverse function is a special type of relationship between its function. But when we invert a trig function, we are just dividing it by a value. We're taking that function and dividing it by a value of 1. Or taking 1 and dividing it by that trig function itself. So before we go out and discuss these relationships, let's go ahead and discuss and draw a right triangle here. And I will call this the right degree angle. And I will discuss this as the angle theta. The leg that is opposite of theta, we will denote OPP as opposite. The one that is adjacent, we will call ADJ to represent the adjacent leg. And then the hypotenuse is going to be HYP. So let's go ahead now and discuss sine, cosine, and tangent. So sine of that angle theta, the cosine of that angle theta, and the tangent of that angle theta. So each of these we discussed in the last video have a relationship, but we'll just briefly review it. The sine, by definition, the sine is the opposite leg over the hypotenuse. The cosine, by definition, is going to be the adjacent leg divided by the hypotenuse, and the tangent is going to be the opposite divided by the adjacent. So sine, cosine, and tangent can be represented by those relationships. Remember, Tom's old aunt, Tom being the T, old being the O, and the aunt. Tom's old aunt sat on her coffin and howled. So you can use that as a way to help you remember these relationships. So now let's talk about what happens when we divide these trig functions by a value of, or when we take 1 and divide them by the trig functions. I always get that backwards. So if we have 1 divided by the sine of theta, this will be 1 divided by the opposite divided by the hypotenuse, and that will give us the hypotenuse over the opposite. And this is how we denote the term or the trig function cosecant of theta. Cosecant of theta is the hypotenuse divided by the opposite, or we're inverting the relationship of sine. If we take 1 and divide it by cosine of theta, we're taking 1 and dividing it by the adjacent leg over the hypotenuse, and this is going to give us the hypotenuse over the adjacent leg, and that is how we define the secant of theta. And that's our next trig function. And lastly, if we take 1 divided by the tangent of theta, and that means we're going to take 1 and divide it by the opposite over the adjacent, and that's going to give us the adjacent over the opposite, and this is how we define the relationship of the cotangent of theta. So there are actually 6 trig functions, sine, cosine, tangent, but there's also cosecant, secant, and cotangent. But make sure to make the understanding that sine will correspond to cosecant, cosine corresponds to secant, and tangent corresponds to cotangent. So I often, to help me remember, I always think about the SC relationship. S is related to C, so sine is related to cosine. Sine will never be related to secant because they both have S's. So the SC relationship helps me understand this. So now let's talk about what happens. Let's talk about what happens when I take the opposite leg in the hypotenuse divided by the hypotenuse and divide it by the adjacent over the hypotenuse. So here, if I denote the opposite divided by the hypotenuse, and I divide that by the adjacent over the hypotenuse, here the hypotenuse will shoot up on top. This is definitely very bright. You can't miss this. And notice we're going to get the opposite times the hypotenuse, is just dividing a fraction, divided by the adjacent times the hypotenuse. And notice these hypotenuse values will cancel, and we're left with opposite over adjacent. And notice opposite over adjacent is equal to the tangent of theta. So the tangent of theta is also equal to the opposite over the hypotenuse, which is the notation, or this is the way we designate the sine of theta, divided by the adjacent over the hypotenuse, which is another way for us to denote the cosine of theta. So this is a relationship that you can also use. The tangent of theta is known as the sine of theta divided by the cosine of theta. But let's think again what happens if we take 1 and divide it by the tangent of theta. And that's going to be 1 divided by the sine of theta divided by the cosine of theta. Okay, this will give us the cosine of theta divided by the sine of theta. And we know cosine by definition is going to be adjacent, the adjacent over the hypotenuse. And we're going to divide that by the sine of theta. And the sine of theta is up here, which is the opposite over the hypotenuse. The opposite over the hypotenuse. And hopefully we recognize that the hypotenuse will cancel. And we're going to be left with the adjacent over the opposite leg. And notice adjacent divided by the opposite is equal to the cotangent of theta. So this is another way that we can represent cotangent of theta, as known as the adjacent of the opposite. But remember, cotangent of theta is just equal to cosine divided by sine. So we can also recognize that cotangent of theta is equal to the cosine of theta divided by the sine of theta. So this is what happens when we invert these trig functions, or take them and put them below the denominator. I'll say put them below a value of 1, taking 1, dividing them by each one of these special functions. So make sure that you understand these two relationships, because they are used very heavily in calculus and your advanced series as well as in trig. So those are very important for us to understand. So now let's talk about even and odd functions. So if you watch some of my prior videos about even and odd functions, let me just do a quick review here. Even functions have a very unique relationship. Even functions have a very unique relationship, and so do odd functions. And in regards to trig, there are more odd functions than there are even. And the nice thing is they do relate to each other very nicely. So remember, even functions we can determine because the negation of the variable x gives you your original function. And odd functions have the relationship that if you negate the variable x, they negate the functional value. So what does that mean? What does that mean? Okay, there's a couple different meanings of it, but more specifically, I like to note some important graphical representations, is that even functions always have y-axis symmetry. They are always symmetric about the y-axis. Odd functions have origin symmetry. Odd functions have origin symmetry. So in order to have origin symmetry, remember, they must intersect the origin. In order to have origin symmetry, they have to touch or intersect or traverse the origin. So this may be a way, if you remember what their graphs look like, for you to remember or to help remember what an odd function is versus an even function. I will tell you that your even functions are as follows. Your even functions is one of them is the cosine function. So cosine of negative x is equal to the cosine of x. The negation of your function gives you your original function. So when you negate any variable, you're going to get back that same cosine value. And that also implies to its inverse when you invert it. So the inverse of cosine is the secant of negative x. So when you invert cosine, you get secant of negative x. And this is also even function. So this will give you secant of x. And that's really important for us to understand. This will help you when it comes to evaluating trigonometric functions. And then now we want to think about our odd functions. And remember that our odd functions have to intersect the origin. You guys are going to love this. The odd functions are every other one of the trig functions. So what are we left with? We're left with sine of negative x. Remember, when we negate the variable x, we negate the entire function. That will negate the entire function. So sine of negative x gives us negative sine of x. When you invert sine, you get cosecant of negative x. So this will give us negative cosecant of positive x. Tangent of negative x is also odd. So this will give you negative tangent of x. And when you invert tangent, you get cotangent of negative x. And this will give you negative cotangent of positive x. So this can definitely help you when evaluating rapidly some trig functions. So let's say that we had an example here. Let's say we had an example for us to evaluate sine of negative pi over 4. And you're like, oh, I forgot sine of pi. Oh, I don't like working with negatives. This is just rough. So what can you do? You can remember that sine is an odd function. Sine is an odd function. Sine will traverse the origin. It's an odd function. All the trig functions that touch or traverse the origin are all odd functions. The ones that don't are evens. So this, by definition, will be equal to the negation of sine of pi over 4. And hopefully we all recognize now that sine of pi over 4 is equal to, sine of pi over 4 is equal to square root of 2 over 2, also known as 1 over root 2, but we keep that negative out in front, so we get negative square root of 2 all over 2. Let's say that I asked you to evaluate cosine of negative pi over 4. And you're like, oh, I don't want to remember what cosine of negative pi over 4 is. I don't want to go ahead and look at my coordinate plane and recognize that I'm going negative or I'm going clockwise pi over 4. I don't want to remember that's what that means. If you have negative pi over 4, your coterminal angle will start revolving in a clockwise direction. But if you remember that cosine is an even function, that this will be equal to the cosine of pi over 4 because it's even. The negation of the variable becomes positive. And remember, cosine of pi over 4 is the exact same thing as sine of pi over 4. And that's going to be equal to a positive value of square root of 2 all over 2. So if you want to, you can try some examples. You can try some examples on your own. But these inverse relationships and this even and odd function relationship can be very helpful when it comes to evaluating your trig functions. Make sure to understand and become very fluent with what is even and what is odd.